Hello everyone, we are the Group 4 from 12 Adam. Today, we are going to talk about standing waves. So what are standing waves? Standing waves are waves that travel in the same place at the same time. These waves are also called stationary waves. Standing waves also results in a phenomenon called interference. These standing waves are commonly seen in musical instruments. The best example of these are wind and string instruments. We can create a standing wave in a tube, which is open on both ends, or in a tube, which is open on one end and closed on the other end. Open and closed ends reflect waves differently. The closed end of a tube is an antinode in the pressure, or a node in the longitudinal displacement. The open end of a tube is approximately a node in the pressure, or an antinode in the longitudinal displacement. The longest standing wave in a tube of length, or L, with one open end and one closed end has a displacement antinode at the open end and a displacement node at the closed end. This is the fundamental. In conclusion, standing wave patterns are produced as the result of the repeated interference of two waves of identical frequency while moving in opposite directions along the same medium. All standing wave patterns consist of nodes and antinodes. The nodes are points of no displacement caused by the destructive interference of the two waves. The antinodes result from the constructive interference of the two waves and thus undergo maximum displacement from the rest position. Midway between every consecutive nodal point are points which undergo maximum displacement. These points are called antinodes. The antinodal positions are labeled by an AN. Antinodes are points along the medium which oscillate back and forth between a large positive displacement and a large negative displacement. A careful inspection of the above animation will reveal that the antinodes are the result of the constructive interference of the two interfering waves. Wind instruments produce sounds by means of vibrating air columns. To play a wind instrument, you push the air in a tube with your mouth or a reed. The air in the tube starts to vibrate with the same frequency as your lips or the reed. Resonance increases the amplitude of the vibrations, which can form standing waves in the tube. The length of the air column determines the resonant frequencies. The mouth or the reed produces a mixture if there are different frequencies. But the resonating air column amplifies only the natural frequencies. The shorter the tube is, the higher the pitch. Many instruments have holes, whose opening and closing controls the effective pitch.